Welcome back to this tutorial series. So in this series we are creating a square root mini app that calculates the square root of a number based on an algorithm. Okay, so the algorithm is a mathematical algorithm that was already written, so we can just use that algorithm. So in this lesson we are going to look at the algorithm, and then I'm going to create the JavaScript code based on the algorithm. Okay, so before we start, let me just explain how the algorithm works. Okay, so you might have learned this in your math class, but even if you hadn't, I'd still like to explain it so you can understand how my code works. Okay, so it's called the Newton-Raphson algorithm or method or whatever you want to call it. Okay, so before the algorithm starts, we are going to have some catch points or some conditions. So first of all, the first condition is going to be if the number is 0, then that means it does not have any square roots, and then the root is also 0. So we'll just return 0 and be done with that. Okay, so it doesn't have to go through the algorithm. So it just ends the whole program at the start once it encounters that number is 0. And then we also have to see whether the number is a negative, positive, or negative number, so that we can return either plus square root, minus square root if it's a positive number, or we can return plus square root I, okay, and then minus square root I if it's a negative number. So you should have probably learned this in your math class as well, because for negative numbers you have to include the imaginary number here. Okay, so now that we've finished the first two catch points, we can start with the algorithm. So this is how the algorithm works. So first, what it does is you have a number, you take a variable or a number, okay, whatever you want, and then you store half of the number in there. Okay, so don't ask me how this works because I didn't create the algorithm. So this is how the algorithm works, and it's a generally accepted algorithm for square root that's used in the mathematical circle, so I'm just using that. So and then we're going to create a loop. Okay, so we're going to create a loop which can be any loop. You can use a for loop, while loop, do while loop, whatever you want. So this square value, that is the number, the half of the number, that value is first stored in a temporary number. Okay, it's temporary variable, and then you're gonna calculate the temporary square. Okay, so you're gonna calculate the square value for as long as the condition is true. I'll tell you what the condition is later on. So what you're gonna do is you're gonna add this, which has the half the number at the start, or later on it's going to have this value once the loop goes back here. So it's going to add that n1 value plus the actual number, the original number, which we didn't change yet, so divided by the half value again, and then divide by 2 finally. Okay, so this is the main formula for our square root. So we're going to keep doing this until the absolute value of n1 minus square is not equal to 0. As soon as this becomes 0, as soon as this value becomes 0, this particular loop stops. Okay, so I'm calculating the absolute value because if n1 minus square is actually minus 4, okay, so the absolute, then that means the absolute of minus 4 is actually plus 4. So that's what absolute does. It changes the sign of the number to plus, no matter what the sign is before. Okay, so you might not understand how this works, just by looking at the algorithm. So let me show you an example. Okay, so let's say the number is 9. Okay, so as you know, the square root of 9 is 3. So let's see if we can arrive at that by using this algorithm. So if it was our program, we'd first look at the if condition to the first catch point, which calculates whether the number is equal to 0. Well, it's not equal to 0, so this condition is false, so it comes below. And if it's a positive or negative number, well, it's a positive number, so our system is going to store that it's a positive number. So later on, while showing the output, it can show it in this format, not this format. Okay, so this is a positive number. So the first iteration of the loop, which is the first run of the loop, okay, so the first, what it does is, so before the first iteration, what this does is, square is equal to 9 divided by 2, which is 4.5. So, and then the first iteration of the loop, so n1 is equal to square, which is equal to 4.5, and then we are going to calculate the square value again. We're going to change the square value, that's why we stored it here, so it doesn't change. Okay, it's a temporary value, n1 is, so it's going to be what, n1 plus, so what's n1, I'm looking at this one, so n1 is 4.5 plus the number is 9 divided by n1, which is 4.5, and then divided by 2. So the final value is going to be 4.5 plus 2 divided by 2. You can calculate along with me if you want to check. And then it's going to be 6.5 divided by 2, which is 3.25. So that's the value of square in the first iteration. So right now is n1 minus, so what's n1 minus square? So n1 minus square right now is 4.5 minus 3.25, which is not equal to 0. So this condition is true. So as long as this is not equal to 0, the loop would run, right? So the first iteration is over, and the second iteration is going to happen because this condition is not yet equal to 0. Okay. So in the second one, the n1, so again, we're going to have our square. So n1 is equal to square. And so far, the square value is 3.25. Okay. Because of the first iteration, the square value is 3.25. And then we're going to calculate the square again. So the n1 value is 3.25 plus the number is still 9. It's not going to change. Divided by 3.25, which is the new n1 value, divided by 2. So that's going to be 3.009. Please calculate it if you want to. So what our program does is, this is actually almost equal to what? 3, but it does not calculate that yet. So we're gonna do our third iteration, because right now n1 minus square is equal to 3.25 minus 3.009, which is not equal to 0. Okay, so it still has to go for the third iteration because we're not getting up the perfect 3 yet. So that's why. So again, n1 is equal to square, which is, in this case, it's just going to take it as 0 because it's just going to take this as 3, because even if you take it as 0.009, it's still going to get the value 3 later on. You'll see that. So the square is equal to 3.009 plus 9 divided by 3.009. Okay, divided by 2. So this actually gives us a 3. So n1 minus square is equal to 3 minus 3, which is equal to 0. Okay. So it stops at this third iteration. So we got our square value. The final square value is 3, which is the square root of 9, and then it will be displayed as plus 3 and minus 3 in the output. Okay, so this is how the algorithm works. So now that we have that, let's create our script. Okay, so first of all, I'll need to get this particular value, the square value, which is going to hold our on-click conditions, because when we click on the square button, then we have to get our prompt, right? So let's do that. So let's first get our document.getElement by ID square, which is the button's ID, and then we're going to add an event listener to this. So what is that event listener? Is the click event listener, which is going to run the following function. I'll just do this as an anonymous function, so I don't want to create the function name here and then add a function definition later. Let's just make it an anonymous function. So whenever we click on this particular square button, what happens is we're gonna get our prompt. Okay, so our prompt is going to ask us to enter the number. Okay, and that number, the number we enter, will be stored in here in num1. But as you know, or maybe you don't know, but every input we get from the prompt is going to be in the form of a string. Okay, and we can't do any mathematical calculation with a string, because string is a string of characters and it's not a number. So we have to convert this particular number, which is in the form of a string right now, to a number. So to do that, we can use one of JavaScript's built-in functions, parseInt method, which calculates a string to a number. So num1, 10. So what this 10 does is, this is the base. Okay, so base 10 is what integer numbers, decimal numbers are. So decimal numbers, the normal numbers that we use, 1, 2, 3, 4, they have the base 10 to indicate that they are decimal numbers, that is normal numbers. Okay, base 2 is binary numbers and so on. So we have to indicate our base here, so it converts the string to the proper number we want. Okay, so also let's create a variable that stores the square root. I'll call it sqrt, and then we're going to create the n1. The n1 here in this algorithm, we had two. We had the square and then we had the n1, which stores the temporary square value every time. So the square is going to be sqrt here and the n1 is going to be sq1. Or if you wanted to, you can just keep it as square and n1, just so you know which one is what from this algorithm. Okay, so and then we're also going to have a boolean variable is positive. Okay, that keeps track of whether the number is a positive number or a negative number. The default value is a positive because most numbers that people are going to enter by default is going to be a positive number. People don't usually enter negative numbers, but we can change this value later on. So that's why it has true now. You can change it to false or whatever later on. So first of all, the first condition is whether the number is 0. So if the number is 0, then you're going to get this particular element and you're going to change the text, which is nothing right now. So you're going to add text in here to indicate that the square root is just 0 because the number is 0. So first get that element, document.get element by id answer, and then you're going to change the inner HTML of that element to the square root of, then again, the number value. The number value is this value which holds a number. Let's remove this. Is going to be s. Let's also give a space here. So s 0. Okay. So what this does is this displays the square root of number, whatever number it is 0. Or if you want to, you can just add all of this together is 0. Okay, so this is how you change the text of an element by using your JavaScript code, by getting the element first with its ID, and then you're going to change the inner HTML. In this case, we are just adding a string to it. You can include any kind of HTML code in here, but I'm just going to include a string of strings with concatenation so that they'll be displayed together. Okay, and then we need to calculate whether the number is a negative number or a positive number. So else if number is negative, that is number is less than 0, then we have to first convert that number to a positive number. So why? That's because, well, as you know, you can't actually do much calculation, the calculations that we need here in our algorithm, if the number is still a negative number, right? So in order to do these calculations, we have to convert the number to a positive number first so that we can calculate the proper square root. But in order to remember that this was originally a negative number, we are going to change the is positive value to false. So later on when we display the output, we'll know that this is a negative number. So we have to display it as phi I minus phi I rather than just phi and minus phi. Okay, so that's it for the catch conditions, and then later on we can start with the algorithm. So this is where the algorithm starts. So the Newton-Raphson algorithm starts here. Okay, so first of all, let's get the square value, which is going to hold the number divided by 2 value. Okay, so that's the first part of our algorithm. If you can see here, we are first going to get half of the number and store it in the square value first. So that's going to be the first value of square. And then we have a condition here which basically says that the absolute value of the temporary square minus the square value should not be equal to 0. So in order to do that, we can use a while loop. Actually, we can use any loop we want, but you usually use a while loop if you don't know the number of times a loop is going to run. In our case, we don't know the number of times a loop is going to run, because based on the number of iterations of the loop is going to differ. For example, in here for the number 9, the iteration is actually 3, but if for the number 4, the iteration is only 2. And for bigger numbers, it's probably going to be more. We don't know, or probably less, we don't know. So that's why we are using the while loop, so that we don't run out of loop iterations halfway. Okay, so absolute, in order to calculate the absolute value of a number, we have to use the math built-in functions. So math.apps, it actually calculates the absolute value of a number of, in here, n1 minus square. Okay, if it's not equal to 0, then run this loop. So as long as the absolute value of n1 minus square that we have here, n1 minus square is not equal to 0, we're going to run this loop. And inside this, first of all, n1 is going to have the square value, so it's the temporary square, and then we're going to calculate, that's this particular line right here. So n1 is equal to square, and then I'll just take this and put it here because that's much easier. So square is equal to n1 plus number divided by n1 divided by 2. Okay, so that ends our algorithm. It's a very small algorithm, just 3 lines of code. So 4 lines of code. So now we have to display the results. So in here we had our catch points. Okay, and now we need to display the results. So if the number was a negative number, our is positive is going to be false. So if is positive, so this is going to be our condition. So what this does is, this is a Boolean value, am I right? So if is positive was true, so this is what it means. If is positive is equal to true. It can also be written as just if is positive. So if it was true, we are going to display the results. So document.get element by id, and we're going to get the answer element, the element with the id answer, and we're going to change the inner HTML of this particular element. So what this does is, similar to this, the square root of number. So that's where the similarity ends from this. So now we have to actually display the square root. R. So what is it? So it has to be plus square root value and then minus square root value because it's a positive number. So plus Okay, we can, since we already gave a space here, we don't need one here. So plus square and then and minus in here square. Okay, so that's what you do if the number is a positive number. Else we can copy this because it's going to be similar, but we're going to have some changes. So the number r plus square I in here. Okay, so I and minus square I right here. Okay, so there shouldn't be space between square number and I. It has to be written together. So that's it. So that's it for our entire program. Now let's check if everything worked. Okay, let's refresh. Okay, that doesn't work. So I probably made a mistake with my code. Let me quickly check it. So everything looks good. Right. So document has to be document. I wrote a document, whatever that means. Okay, now I've saved it again. Let's refresh this. Still doesn't work. And that's probably because I haven't entered my semicolon. I'm so sorry about this. So 2 mistakes. So one is this document, and then there is at the end this particular semicolon, and finally I need to link my script with my index because I didn't do that for my style sheet. Remember, I should have. It's usually better to do all of that at the start of the code itself so you don't forget, and I forgot to do that. So script source is going to be script.js. So if you don't enter this, then your code won't know that this particular script file is for this particular HTML file. So always link everything. So let's check our output again. Great, so now it works. So let me give a positive value first. 25 gives the square root of 25r plus 5 and minus 5. And if I give minus 25, I'll get square root of 25r plus 5i and minus 5i. So this part is correct, but this part there's a small mistake with this place. Where is it? Well, square root of, I'll add minus here, okay, and then let me remove the space here. So there's, if you can see here, there is space between plus and minus and the number. So let me remove those. Plus 5, minus 5. So I should get that now. So reload and then minus 25 square, correct. That's correct. The square root of minus 25r plus 5i and minus 5i. Similarly, let me remove the space here as well. Okay. So that's it for this lesson. So as you can see here, we've gotten all our outputs properly. So everything works. So in the next lesson, let's look at how to do the same thing without the algorithm. As in, JavaScript has a lot of built-in codes and built-in functions, so we can use those to reduce the lines of code. So for example, this particular algorithm, just the algorithm took about 15 lines of code, right? So we could reduce those 9 lines of codes and get everything in just one line of code. So that's how JavaScript built-in functions are useful. So let's look at that in the next lesson. So I'll see you there. And please subscribe, like, and comment on the video. If you have any doubts, please feel free to ask me in the comment section. I always reply. And also, if you have any suggestions for future videos or other mini apps I could create or other premium courses, ideas for courses I could create, whatever it is, please comment about all of those below and I'll get back to you. Thank you.